Okay, sorry, lines and planes part 1. I'm just finishing question 5. Okay, question 5 is a plane passes through those 3 points. Write the vector and parametric equations, first step. Okay, so to write a vector and a parametric equation of a plane, what do we need? We need 2 direction vectors and a point? No. Yes. And a point. So we have 3 points, so we can make 2 direction vectors out of that. Okay, so I'm going to use the vector. You could get a different answer than me in PS, depending on which direction vectors you use. I'm going to do AB and AC. So for AB, I got -3, -19, 3. And for vector AC, I got -2, -14, -5. So I got 2 direction vectors. So I'm actually going to take the cross product of those 2. Oh, wait, what am I writing here? Oh, sorry, I'm getting confused. So for question A, it says vector and parametric equations. Okay, so I'm ready to go. So my vector equation is xyz equals, I can choose any point, so I'll just pick point A, which is 1, 13, 2 as my position vector, and then those are my 2 direction vectors, and I'll just put a letter in front of them, a parameter, so t, -3, -19, 3, plus s, -2, -14, -5. So even if you used vector BC or CB or CA, it doesn't matter. Just pick 2, just get the vector between 2 points, 2 of them, and you're good. Okay, and then our parametric equations are just when you do the x, y, z. So I got x equals 1 minus 3t minus 2s, y equals 13 minus 19t minus 14s, and z equals 2 plus 3t minus 5s. So those are my parametric vector for part A. Then for part B, it says to write the scalar equation. So I know that when I write the scalar equation of a plane, I need the normal vector because that will give me the coefficients A, B, and C for my scalar equation. Remember, scalar equations in the form ax plus by plus cz plus d equals 0. So I'm going to take my 2 direction vectors that I used, and I'm going to do the cross product normal in order to get the normal vector. So when I do the cross product, so like the ijk thing, and I do it with my vectors, 3. Okay, I already did this myself. Oh, you know what? I should just show my work though. -3, -19, 3. -2, -14, -5, -2. Oh my gosh, these are getting crazy. I gotta redo this. Sorry, guys. -3, -19, 3. -3, -19, 3. -2, -14, -5. -2, -14, -5. They're all negative. I could have made those all positive. That would have been cool. Oh well, sticking with my original. Okay, so cross product's gonna be 19 times -5 minus -14 times 3, which will give me 137. Next step, -6 minus 15, so -21. And final one, -3 times -14, so 42, minus, where am I here? 38, which is 4. Yeah. Okay. So that's your normal vector. You just do cross product and boom, you got A, B, and C. So now we know 137x minus 21y plus 4z plus d equals 0 is the scalar equation of our plane. And to get d, we just sub in any points for x, y, and z. And we were given 3 points at the start of this question. So why not just sub in any one of those points? So I'm going to pick point A. So 1, 13, 2. So then I'm going to, once I do all that math, I'll figure out that d is equal to 128. So my final answer for this question is 137x minus 21y plus 4z plus 128 equals 0. Scalar equation of the plane. Okay, final one, C. Determine 2 other points on the plane. I think your easiest bet here is to, where are we? Use your parametric equations and just pick any values for t and s. So there's like a infinite number of answers here, but I would just use my parametric guys, and then I would just do, like, for example, you know, pick easy ones. Let's pretend t is 1 and s is 1. And then when you sub those in, you know, you'll get x equals 1 minus 3 minus 2. So that's negative 4. Y is equal to 13. I lost my parametric. Minus 19 minus 14, which is negative 20. And z is equal to 2 plus 3 minus 5, so 0. So 1 point on my line could be, or on my plane could be negative 4, negative 20, 0. And they just do the same thing, but just pick another value for t and s and sub them into your parametric. I think that's the easiest way to find points on a plane. Rather than like trying to pick, you can do it this way too, but pick any points for, you know, 2 of the variables and then solve for the 3rd variable. You're probably going to get ugly points. So, okay, the end.